Hi everyone. In this video, we are going to solve a new problem. The problem is find duplicate subtree and the problem number is 652, right? So first of all, we are going to clearly understand what this problem says. After that, we are going to move to the logic part and after that, we are going to implement our logic in C++, Java and Python programming language. Fine. Now let's see what this problem says. Given the root of a binary tree, return all the duplicate subtree. Alright, so we are given the binary tree and we have to return all the duplicate subtree which are exist in our binary tree, right? For each kind of duplicate subtree, you only need to return the root node of any one of them. So guys, there may be the case we can have 3 or 4 duplicate subtree in our binary, right? Of same kind. So we don't need to return all these 3 or 4 duplicate subtree. We just need to return only one duplicate subtree, right? Okay. Two tree are called duplicate if they have same structure with the same node value. So they have given just the definition of duplicate. So let's understand this from this. So let's say we have 3 and also 1 3 and these are connected with this particular root node 9, right? So 9 has left 3 and right 3, right? So can you tell me guys how many duplicate subtree are exist in this particular tree, right? So let me take this tree. So let me take this tree. Fine. So how many duplicate tree exist in this particular tree? So you can see that we have nothing but one duplicate subtree. This is nothing but this one, right? So 3 has come 2 times. So this is nothing but duplicate subtree. It is not like that 3 has come 2 times because we can see this if we consider from there. So we have nothing but a root node 3 and root node 3, right? So these are called duplicate subtree, right? So we can say for now in this particular tree we have one duplicate subtree, right? But if I just little bit expand it, we have 3 to 6 left node and also left node. So can you tell me how many duplicate subtree we have right now? So guys, you can focus here. You can say that there are two duplicate subtree, right? So the first one is this one. So you can see this has come 2 times, and the second one is nothing but this one, right? I hope this makes sense. So if I just expand it little more, then you can tell me. If I say this is nothing but now this is a tree, then how many subtree? Three, right? Isn't it? So here is nothing but three duplicate subtree. But if I just little bit more expand it, 3 to 4, and here also 4. Now guys, can you tell me how many duplicate subtree we have? Yes, there is a two subtree, right? So there is a two subtree. First one is this one and second one is nothing but 7 node. But can you focus here? There is a 3 subtree, 4 also. So there is nothing but 3 duplicate subtree exit for this in this particular tree, right? So now guys, by this example, I hope you understood about duplicate subtree for this particular problem. So these were the duplicate subtree, right? Now let's move to the example 1 and let's try to understand from example 1 what this problem want to say, right? So now let's see the example 1. So guys, this is nothing but example 1. All right. So we are given with this particular tree and we have to return all the duplicate subtree, right? Fine. So guys, can you tell me how many duplicate subtree here? So there are two duplicate subtree. The first one is nothing but this one. So you can see that 2 to 4. So this is nothing but a duplicate subtree. So we are going to return 2. Now remember one more thing guys here. We are going to return root, nothing else. We are going to return root. So in the output you may see something different, right? Say they have traversed something to have 2 comma 4 they have traversed, but we don't need to traverse and return them. We just need to return the root of that particular tree or duplicate subtree, right? So here I'm going to return 2 because 2 is the root of my subtree, right? So I'm going to return 2. Fine. And the next subtree which is common or we can say duplicate. So this is 1, 4, 4 and 4. And we have seen that guys, if any duplicate subtree coming more than twice, right? We need to return only one, right? If subtree is coming 3, 4, any number of time, we just need to return only one time. So here we are going to return 4 only one time. So in the output also you can see that 2 is a root node and 4 is also root node. So I hope now guys by this example you must have a better idea about this particular problem, what this problem want to say and how we can solve this particular problem. We are going to see this particular part right now. So let me write here logic. So now let's discuss about how we can solve this particular problem. So guys, what should be the logic? How we can solve this particular problem? Which algorithm you think that is best suitable for this particular problem? So what I am getting is nothing but DFS, right? So I'm thinking that so DFS is gonna be the best particular algorithm for solving this particular problem. But can you tell me any other approach? If you have any other approach, you can write in the comment section. I will definitely gonna look that, right? So I'm gonna use a DFS and how you can see. Let me draw first of all this particular tree: 1 to 2, 3, 4, 2, 4, and 4, right? So this is all about our tree, right? So now guys, I'm going to use nothing but DFS and I'm going to maintain a dictionary. And why I'm using a hash map data structure, you will find out, right? So nothing but what I can say, you can see guys 4, right? So I'm going to use the DFS. So first of all, I'm at root node. I'm going to call right node, then left node, right? All right. So for right node or left node, I'm going to call fill again left node, then right node. But there is no right node, so it's going to call left node only. So here for this particular node also, I'm going to call left node and right node. So there is nothing. So it's going to return something. It's going to return its particular root node only 4, right? So we are going to return 4 and I'm going to say if it is returning then it should be 1, right? Okay. So now guys, think about this. I'm going to take this particular thing with a string. So I can write here nothing but 4, right? Fine. Now it has written 4 to this particular parent as well. So there is nothing on right, but there is something on left, which is going to return by this particular node, right? That is nothing but 4. So focus over here. 2 is gonna, so first of all, I'm gonna write here 2. Fine. I'm gonna write here 2. Then by underscore, I'm gonna concatenate its left part, that is 4. Fine. And by underscore, I'm going to concatenate its right part. And there is no right part, so I'm going to concatenate nothing, right? And it is going to be nothing but one time. Fine. Now I'm not going to return anything to the one because I have to call this particular one is going to call for right side as well, right? So we are going to move to this particular part 3. I know you, I believe you know DFS, how does it work, right? So we are at 3 and 3 is not a root node. So it's going to call first of all this particular 2, then 4, and 2 is also not a root node. So it's going to call 4 and 4 is a root node. So it's going to return nothing but 4, right? So guys, can you focus over here? 4 is already present in my dictionary. So it's gonna return nothing but I gonna say it is not one time, it is gonna coming a two time. And you can see whenever I'm getting a two time, I'm gonna nothing but I'm gonna appending it in my result. So I'm gonna say my result have 4. So because it has come for two times, right? And whatever coming two times, that means this is a duplicate subtree. Okay, now 4 is gonna return something to the 2. It is gonna return 2. So again, I'm going to say that 2 is nothing but I'm gonna write here 2, and I'm gonna with underscore I'm gonna we can say I can say I gonna concatenating the left part, that is 4, and with underscore I'm gonna concatenating the right part, but there is no right part, so I'm gonna leave it as it is, and I'm gonna make it 1. But can you focus it? It is already present in my key, so it's gonna make it, I'm gonna make it 2, and it also coming two times, so I'm gonna appending 2 also in my, we can say, result, right? So 2 also gone in my result because 2 node I'm getting that particular we can say the value 2, right, of my key. Fine. Now it's gonna return to 3, and 3 is nothing but I'm gonna write 3. The left part is nothing but, let me write it 2 comma 4, and here also 2 comma underscore comma 4. Fine. So I'm going to write 3 by underscore. I'm going to append the right part, left part, sorry, and the right part is also gonna be something like 4, right? So I'm gonna say 4. So these are also gonna have underscore on the left side and right side, right? I hope this makes sense. Fine. So you will know better once you will draw it. But here for your understanding, I'm just doing this, right? So now one will, what will one have? So this is having nothing but 3 underscore 2 underscore 4 underscore, and underscore we're gonna say 4 underscore underscore anything, right? So one is gonna have 2 underscore first of all 1, the left side 2 underscore 4 underscore, then the right side 3 underscore 2 underscore 4 underscore. But you will see that all these keys are not same, right? So they are not going to be become 2, right? So they're going to be remain 1. But this one 2 underscore 4 underscore 2 underscore 4 underscore is going to be repeat, so it's going to be become 2 one time, and whenever they are becoming 2, so we are going to appending in our 4, right? Oh, sorry, we are going to appending in our result. And 4 also, but here if you notice here 4 also becoming 3 as well, right? But we are not going to append it. Why? Because we are going to append only when they are going to become equal to 2, right? So because we don't want to take all the duplicate subtrees. So here also you can see that in the example one also we are having 4 4 4. So we're going to have 3 times, right, duplicate subtree. We are going to append only one time. In the output you can see we are going to have only the one time. So I hope you are getting this particular thing. We are going to just maintain the DFS, depth first search, and we are hash map. And whenever we are getting a value 2, we are going to appending in our result, right? So this was the logic for solving this particular problem. And if you still have any kind of doubt, don't worry. By the implementation part, you will have a better idea. And now let's see how we can implement this particular logic in C++, Java, and Python programming language. So now let's move to our implementation part. Right. So I'm here with the first programming language, that is nothing but Python, right? So what I'm going to do, I'm going to first of all maintain, we can say result. So which is going to be list, right? So we have to return here. And first thing which we are going to maintain, that is nothing but, let's say, dictionary, right? We can say hash map, which is going to be empty. Let's make it a collection dot default date, and we can say integer, right? Fine. Now I'm going to maintain a function define solve, which is nothing but a DFS, let's say, right? So left, if I write here nothing but, this is going to be nothing but DFS. Fine. And it is going to have root node. And we can say if there is not root node, right? If there is not root node, if root not root, then you can say return empty string, right? Fine. But if it is a root exit, then what we are going to do, we are going to say concatenate. So we can say value is going to be nothing but, I'm going to say root dot, let me add in a string, root dot val plus concatenate with the underscore, right? So we can say underscore plus, we can say whatever the value we are getting from left side. So define, so let's say not define, let's call it solve root dot left part plus underscore, and whatever the value on the right side, right? So I'm going to say solve, let me add solve root dot right side. I hope this makes sense. Once we got a value, we're going to put in our dictionary value plus equal to 1. If value is equal to, let me add dictionary dot value, if it is equal to 2, right? If it is equal to 2, that means that has come twice, right? So that is nothing but a duplicate tree. So we are going to say nothing but, we're going to say result dot append that particular root node, because it will come to on that particular root node, right? So we are going to append that root node. After that, we are going to return our value. So let me call this function for root and let me return our result. So let me run this code and see whether we are getting answer or not. So this is just simple 10 line of code. I believe you understood this particular thing. If you still have any kind of doubt, you can ask in the comment section. You can see all the test cases are passed. Let's try to run this code, submit this code, and this successfully submitted as well, right? So you can see there. Okay, let me close this. Now let's move to the another programming language that is nothing but C++, right? So here also we are not going to do nothing. We are just going to define first of all our list. So we can say vector, and this is going to be a data type is going to be tree node. All right, and after that we are going to give a name result. And also one more thing we are going to define that is nothing but a dictionary, or we can say hash map. Here we are going to use it an order map, and this is going to be first of all string and then integer, right? And the name I'm going to give is dictionary, right? After that I'm going to define nothing but a string sol function, right? And this function is going to use a tree node which is going to be root. And if root node root, right, if node root, then you can return nothing but empty string. But if it is root exit, then you are going to calculate the string, or we can say the key, that is nothing but going to be nothing but first of all we are going to add to string function to convert this integer value to a string, and then we are going to concatenate with underscore the left side. So we are going to say sol root dot not dot we can say left side, and then also we are going to concatenate with the right side. So we are going to say plus sol root right side, right? So once we done this thing, we are going to also put this particular value in our dictionary. So I'm going to say dictionary dot value plus equal to 1, right? And after that we're going to check it. If dictionary dot value is equal to 2, then what you have to do, you have to just append it. You have to result dot push back this particular root node. Once we are done this, we are going to return our result, sorry, value, right? Value is nothing but key, right? After that we are going to call this particular function sol, and we are going to call with our root node, and after that we are going to return our result. So now let's try to run this code, and let's see whether we are getting any error or not. You can see that all the test cases are passed. So let's try to submit this code. And this was a very easy problem, right? Isn't it? By seeing the implementation part, you can see it is an easy problem, right? Now let's move to the last programming language, that is nothing but Java. And here in Java, so we are going to define first of all at the top list of tree node, and which is going to be nothing but the name I'm going to give result and list array list. Okay, and let me do this. Once we are done this, we are going to define also a dictionary or a hash map. So I'm going to say hash map, and this is going to be data type string, comma integer. And after that, we are going to give a name nothing but dictionary new, let me write new hash map. Fine. So once we are done this, we are going to define one function that is going to be nothing but public. We can say string, let me write a string, and the name of the function I'm going to give sol, and this is going to be tree node of root. I hope this makes sense, right? Fine. Now once we are done this, we are going to say if root is equal to null, so that is an empty, right? We can return we can say empty string, right? So we are returning empty string if root is null. But if it is not null, we are going to find our key. So the key name is I'm going to give value, and it is going to be nothing but first of all we are going to say root dot value plus, and here I'm going to concatenate this string this root dot value with the left part. So I'm going to call it sol plus sol left side, root dot left side plus, I'm going to concatenate with this right part as well. So I'm going to say sol. So let me write a plus sol root dot right part. So once we are done this thing, we are going to put this particular key, we are going to append 1 in our key, right? So we are going to say dictionary of this particular key should be incremented by 1. So we can't do this in Java, right? So we have to say dictionary dot put, we can say value, or not, we can say value, we can say, yeah, we can say value. After that we have to find what are the key present over there, what are the value of that particular key if it is already present. So we can say dictionary dot get if it is already present. So we are going to say get to default. It may be the case it's not present, right? We are inserting first time, so we can say get to default if it is first time. So we can say give us 0. If it is not a first time, then give that particular value, right? And after that we are going to append just one more it, right? So we are inserting one more value, we are going to inserting one more value, right? So once we are done this thing, we are going to say if dictionary dot, or we can say dictionary dot get, and this value is equal to 2, that means it has come twice, that means this is a duplicate subtree, right? So we can say result dot up add, and we can, what we can add, we can add this particular root, and we can just simply return our key. We are returning this string key because we want to give this particular key to the parent as well, right? Now we are calling this particular function, so root for solving root, and after that we are going to return our result. So we are calling first of all this function. This is going to iterate over all the subtrees, all the, we can say all the childs of a particular root. And once we are done this, we are going to already store all the data, or we can say all the subtrees in our result, and after that we are calling this particular result, right? Now let's try to run this code. And If it got submitted, if it got accepted, we are getting a error. We are saying that string is not a functional interface, right? So what we have done, so we have something, okay, we are not using here, we are using a C++. We have to use root.well, right? Fine. Now let's see. And now you can see all the tasks passed. So now let me summarize it, right? So because this is the last programming language. So first of all, what we are doing, we are maintaining a result which we are going to return. So it is going to be written, and this dictionary is nothing but we can say that this dictionary is going to be store the keys, right? So we can say it's going to store the key. It's going to tell us that how many times that particular structure has come already in our tree, right? So now we are going to call this function solve, and we are going to iterating over the left side and right side. We are maintaining a key. We are maintaining a key, and once we are putting it, after that we are putting that particular structure in our we can say hash map, right? If it has already come, so we are appending one. We are going to say if it has come one time, so now it's gonna be two time, right? Now we are checking it. If it has come two times, that means it is a duplicate tree, right? So we are appending that particular root. And after that, we are going to return that particular key to the parent node, right? So, so that they can also use for their particular parent node. Fine. Now let's try to submit this code. And you can see that it also got submitted, right? So that was the problem. I hope you understood this, right? So it was an easy problem, right? So if you still have any kind of doubt, you can ask in the comment section. I'm always there to help you. And if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.